So hello everyone, this is day 37 of my journey to improve my communication skills. And tomorrow I have an exam and I prepared for that. So basically I have an interview in learners tomorrow. First one is cloud computing and another one is machine learning. In the morning session I have a cloud computing and the evening session I have machine learning exam. And cloud computing is basically very easy subject. We need just mug up the things and write in our own words. In machine learning, there are some concepts, some algorithms, some kind of numericals, which is very difficult and a little bit hard, but not that much. However, if if we study continuously from the past 2 or 3 days, we can easily manage them. So there are 2.5 modules for the machine learning algorithm, machine learning exam. So in the first modules, there are two questions. First one is back propagation and SVM. Back propagation is basically an algorithm through which we can calculate the we can train them neural networks on the basis of the error. We can reduce error at every step using the gradient descent. This is basically the back propagation. And there are a couple of steps to solve the back propagation problem. First of all, we should initialize the weights, and after initialize the weight, we have to compute the hidden values and the output value. And after calculating the hidden and output value, we need to calculate the error coming from the target target output to the uh, expected output. Once we will calculate the error, if we are not satisfied from the error, we will backtrack and we will again calculate the error at every point. We will update the weight and follow the step until or unless we are not satisfied with the weight. This is basically the backward propagation. SVM basically is a support vector machine, which main function is to use is basically a supervised learning algorithm. Its main function is to classifying the objects, classifies using the optimized hyperplane. So basically, there are two types of SVM. First one is linear SVM, and another one is non-linear. So linear basically is when we can separate the data using a straight line. It is easy to implement, and it can basically for the normal data, not complex. The complex data we have to use non-linear. And if we have to convert the non-linear data to the linear data, we have to use kernels. There are different types of kernels, probabilistic kernel, classified kernels, a lot of kernels are there. So the main purpose of the SVM support vector machine algorithms is for classification. And its applications are first of all image recognition, complex data recognition, and prediction also in some cases. So in the module 4, there are a lot of stuff: Bayes theorem, uh, Naive Bayes theorem, and then K means clustering, KNN classifier, and the EM, which is basically expectation maximization algorithms, which is used to calculate the hidden values, what are the hidden values in the program, and it will reduce the error every step. It's basically like boosting algorithm. And after that, there is a topic like Bayes classifier, the fifth module, random forest, then decision tree, then random forest, decision tree, stacking, uh, tag, which is most important, characterize cyclic graph. After that, tag, random forest is done, decision tree is done, ADA boost, which is most important in the last module. And one of the most important fifth module is Q learning. Q learning basically an algorithm, reinforcement learning algorithm, reinforcement learning on the rewards. We can take the steps, we can take the optimized step using the rewards which we get from the environment. For example, if we are driving, if self-driving car without any human being, so how it will learn with the reinforcement learning. So basically, if drive safely, it will get reward. If it hit collision or hit the car, then it will get the negative points and it will learn accordingly. So that is basically the Q learning algorithms. So in our case, we have been given in the matrix some weight function some random weights. We need to calculate the fast impact multiplier with the formula of um, S comma A is equals to rewards what we are getting at every step. Then again S comma A plus gamma into maximum of Q of S comma A. Whatever the new state is coming and the reward we are getting, we will find the maximum of that state. So yeah, that's all for today's video, and this is the day 37th of my journey to improve my communication skills, and I will continue this journey forever. So thank you for watching.